I'll do some quick introductions. Just welcome again, everyone, to our NACAA 365 webinar. Today, we actually have three individuals from Bayer Crop Science. Jim Ruscosi, as many of you may know, was a former extension agent and now works for Bayer and is in the California area. And bear with me just one second. And also with us, we have Denise Bouvrette. I may have messed that up, but Bouvrette, is that correct?
You did well.
All right, Denise, she's the corn project manager and launch lead for the North America product management with Bayer Crop Science. And also joining us hopefully here in the next minute or two will be Ryan Tichich, who is the North American Corn Agronomic Systems team lead with market development. And from what I understand, Ryan is a former extension agent from the great state of Wisconsin.
He is.
Jerry Clark, one of our former regional directors, informed me of that when he saw Ryan's name. So I will hand it over to Denise. Thank you for joining us. We look forward to hearing your comments.
Well, thank you so much for the invitation. Really happy to be here with all of you today to talk about our great pipeline and some of the cool stuff we've got going on over here at Bayer. Yes, I think when we received the invitation, Ryan and I talked about what we'd want to share, and he mentioned that he used to be a part of this organization. So great to be here, and thanks for the opportunity. Just my caveat statements, a lot of what we're going to be talking about today is certainly forward-looking as we share some of the innovation in our pipeline and some of the next to launch products that we have coming from Bayer. So just know that anything and everything that I say could change. And thanks for the great introduction. We just had this slide in here just to remind you of who we are when Ryan joins. Again, he leads our corn agronomic systems team within our market development group. And I am the corn project manager and launch lead for North America. So we're happy to be here with you today. So we thought we'd give you a little bit of background just about our company and the crop science division within Bayer. And so I really like this slide because it just demonstrates at a glance what our product segments are, our geographies, and the investments that we put particularly into our R&D budget. So, our crop science division generated about 18 billion euros in sales in 2020. And we put a lot of that back into our R&D organization. So about 2 billion of that is reinvested into our R&D innovation pipeline. We've got over 33,000 employees and we're active in over 140 countries within our crop science division. So we certainly have a pretty big footprint globally, and our main goal really is to deliver that world-class innovation and really set new standards for sustainability for our growers. This slide indicates, kind of the R&D investment that Bayer puts forward compared to some of our competitors. And we invest in our seeds and traits business as well as our ag chemistry. And I think this is one of the biggest reasons that Bayer and Monsanto merger happened a few years ago, and it really highlights the driving forces behind that, as we wanted to bring together the best-in-class crop protection business with the best-in-class seeds and traits, and bring in that digital component as we start to think about how farming is continuing to evolve and get more digital and more data-driven as we move forward. Our R&D organization has over 7,000 employees in over 50 countries. So we have a pretty big investment in this space. Our innovation pipeline really goes through the whole gambit of things. So, we have our seeds and traits within our breeding pipeline. That's a global organization across multiple crops. And we feel that we have that leading germplasm library across all of those crops. Our biotech technology is really where our new innovations and biotech GMO traits come in to give us that tolerance to our herbicides, the pest tolerance, and the next leading generation of short stature corn that will be coming. Our chemistry, of course, we have a strong discovery platform in our chemistry pipeline to really search for those next new molecules and new modes of action to bring forward from a crop protection perspective. And we try to pair these together between our greatest genetics, the leading agronomic traits, as well as our chemistries to really provide a whole package to our growers for full protection and of the yield that they can get in their fields. We do have some biologicals in this space as well that we're exploring to enhance our seed treatments and really get those plants off to the best start. And then a whole new space in digital farming where we're using all the data we can capture from the field to really inform our data science models and start to get better at predicting how to best get the best outcomes and how we manage these crops. And combining that with all of our great products really provides a full solution for our growers. So this slide illustrates our core pipeline. This is the North America traits pipeline over the next decade. As you can see, we've got quite a few new products in the pipeline, a couple that we'll talk about today. This is showing across crops. So we have our SmartStax PRO technology was our next generation corn rootworm trait that we're launching next year. So we'll talk a little bit about that today. We also have our Thrive On, which is launching next year, we think, in cotton, which brings that protection against the thrips. We have a Corn Rootworm 4 in the pipeline, which is really exciting. We'll touch on that a little bit today as well. But that's 2 new BT proteins that will be coming along, which is pretty cool and exciting. Next generation bugs in both cotton and corn coming later in the decade. Our Smart Corn system, which is related to really enabled by our short stature hybrids, we'll talk about today as well. We have multiple technologies in the pipeline to deliver that to our growers. And then our herbicide platform in blue, in both corn and soy, the next generation herbicide tolerance traits coming mid to late this decade to the early 2030s. So the purpose of this slide is really just to give you a highlight landscape of the innovation pipeline we have. I think Bayer continues to be committed to being that leader in innovation and bringing these new solutions to our growers to address the biggest challenges that they have on their farms every day. So I'm going to talk to you about the short stature corn technology first, and then we will jump into the corn rootworm technology. If Ryan's able to join us at that point, I'll turn it over to him. If not, I'll cover it all for you today. So I am super excited about the short stature corn technology. This is something that we've been developing for some time in our portfolio, and we've really been working to understand what this technology can bring to our growers and the doors that it could open up. And we've hit several milestones in the development of this product concept, and so it's really exciting to see this shape together. As I mentioned, we have multiple technologies in our pipeline to create a short statured corn hybrid. They're in different phases in our development pipeline. Our traditional breeding approach is in phase 3. That's primarily what I'm going to talk about today because it will be the first to launch in North America. And that's really because it's a native trait, so we don't necessarily have to go through our regulatory approval process. So there's no regulatory barriers to getting this product out to market. But we do quickly have behind it our biotechnology approach for the short stature corn. So this is starting the regulatory process now. It's also in phase 3. And so this will come out hopefully at the end of the decade, pending all those regulatory approvals. And then we still have some additional approaches to create short stature hybrids in discovery in our early pipeline. And that's through genome editing. So this is another approach to actually go in directly to the genome, modify that genome to create a shorter stature corn. So we have multiple technologies that we're taking to create short stature hybrids. And that level of investment, I think, showcases our confidence in this product concept and the value that it can bring for our growers. And so we're certainly dedicated in bringing that forward. This photograph that you see here comes from Iowa. I think it was in Newark, Iowa, in the summer of 2020 when the Dirichlet Storm ran through that state. And so this is a picture of one of our pipeline fields. The red boxes are circling the short stature corn hybrid plots within this field, and you can see the lodged corn all around it. This particular field experienced winds of 50 to 75 miles per hour during that storm. It wasn't the worst location, certainly with the derecho, if you've seen any of that data of the wrath of that storm, but it certainly was a significant wind event. And we have lots of examples of this inherent standability with these short stature hybrids in multiple years. And so this is a really exciting product where, you know, just by shortening that plant, we see inherent standability in these wind events. And that's really decreasing the risk of lodging and green snap for our grower in significant wind events, but also just those partial losses that our growers experience every year due to lodging and green snap events. So these plants are much more tolerant to that and can stand with quite a bit of pressure. This is a global product concept for our short stature hybrids, but we do think each of these regions has a little different flavor on what the biggest benefit and value that these hybrids create for our growers in those regions based on the challenges that those growers have. In North America, we're certainly focused on that production stability, given that improved standability. So that tolerance to the wind events, we're seeing increasing numbers of wind events and weather challenges for our growers throughout each season. And so this product just brings along a reduction in that risk every single year and gives the growers confidence that that corn's going to still be standing by the time they try to harvest it. We also think that there's a great benefit for growers here in the US and in North America around precise crop application. And this is because we're lowering the plant height by about 30%. So today's corn hybrids range, I don't know, between 9 and 12 feet. The short stature hybrids will be about 5 to 7 feet tall. And so you can certainly understand with that level of plant height that there's standard ground equipment that can easily get over the top of that crop all season long. And so that's a pretty exciting opportunity to give growers more flexibility in when they can apply crop protection and inputs to their plant fertility, for example, and how precisely they can apply that with different types of equipment. In other world regions, other aspects of this product concept are even more important around in EMEA. They're certainly looking at silage quality. Certainly areas in the US that's important too as well. We have some early data that would indicate that these shorter hybrids have really good quality and combined with the standability that could offer a great benefit to many of our growers. We also see some pretty cool data around the roots of these hybrid exploring more soil volume faster, which could indicate that they may have the potential for increased stress tolerance. And so just having better access to nutrients and water for when those stressful times of the season happen. We're still evaluating that, but it certainly is some early indications that we might have some better root development and increased stress tolerance. When we think about the product concept for our short stature hybrids, there are some inherent benefits of the hybrids that make us think, we can really evolve how we produce corn. And the first I talked about a little bit already is really around the protection. So that reduced risk of yield loss because of the inherent standability of these hybrids. On average, if you look at the data, anywhere between 5 and 25% yield loss each year due to lodging, and it could be even higher in instances of green snap. And so that's a pretty significant yield loss that you're protecting just by the inherent standability of the shorter stature plant. The access all season long for more timely and precise application of the inputs with your standard equipment. What's pictured here is one of our sprayers standing in the field of short corn, really opening up a window for growers to have more flexible access to their crops. And then the yield potential comes along with the ability to manage your crop differently and get those inputs on more precisely and timely, but also in the ability to push populations. So the standability of these hybrids really allow you to push populations even in your standard row spacing at 30 inches for corn, higher than you can with tall with less risk. And so that gives you the opportunity to think about how you can produce more on every acre. So I mentioned the Dirichlet Storm, so I wanted to just show a little bit about this to share with you what really happened in that storm. And some of you may be pretty familiar with this. It was a pretty once in a lifetime storm. This picture kind of shows it spread over time and intensity over time and across the swath of land that this covered. And I think overall the damage was pretty, I don't remember exactly how many acres were lost during that storm, but it was pretty significant damage. You can see pictures here of silos and equipment that was damaged as well. And in areas that experienced the 140-mile-per-hour winds, the corn did not stand, not even the short corn. So it's certainly not derecho proof. And when silos and trees are falling down, I think you can expect your corn to fall down as well. However, there certainly were areas where the wind events were less than that, 75, 80, 90-mile-per-hour winds, less than 50-mile-per-hour winds. And in those areas where we had trials, so these little triangles up here indicate all areas where we actually had short corn trials, some of them directly in the swath of this storm, we saw some great data. So this was a unique opportunity for us to be able to characterize this resistance to lodging and the wind resistance that these crops have. And we're really happy with that data. I think I already showed this one, so I'll skip to this one. This is a picture from just this past year up near the Field of Dreams location. So if any of you have been out to the Field of Dreams, this was a few miles down the road from there. The airport nearby registered 90-plus-mile-per-hour winds after a tornado warning came through this area. And here's our plot of short corn in that field that's still standing fairly well. You'll see it's not perfect, but again, that's 90-plus-mile-per-hour winds. From an in-season access perspective, I wanted to call out a couple of things, specifically what the grower will be able to do. And there's two main components here from an access perspective that I think are cool. And the first is your early access. And so short and tall corn don't really distinguish themselves in the field until about anywhere between V6 and V10, depending upon the hybrid and the environment, is really when they start to differentiate themselves, and you'll see the tall corn elongate beyond where the short corn is. So up until that point, your weed management program would likely look very similar. But one thing that we noticed is that you actually have about a 5 to 7 day extended window to access your crop with a toolbar. And this picture is showing your tall on the left and your short on the right against that toolbar backdrop. And so that 36-inch toolbar clearance, you actually have about an extra week or so to apply side dress to your crop, and gives you a little bit more flexibility on that early fertility timing. And again, as I mentioned, you really do have all season long access with other types of equipment, like your standard ground sprayers and whatnot, where you're going to have clearance. If you have a machinery that has at least 5 feet clearance, you'll be good, and you can use that for any of your in-season crop applications with short stature corn. So you won't necessarily need a high boy, and you could potentially shift your applications from aerial to ground applied if the grower chooses so. This is a photo of one of our climate fields. And so this was a fairly large field where we experienced 60-mile-per-hour winds This was a high population field, so it was 39 to 40,000 seeds per acre. And the left was our tall, which you can pretty much see through the storm, was lying down, and our short was standing tall. So we we certainly see consistency in that standability aspect. And then these types of fields where you're typically applying your aerial fungicide, you can think about applying through standard ground equipment. We also see extended standability well into the season, which could potentially extend the harvest window for our growers as well, and just ease of harvest, because you know that your corn's still going to be standing when you get out there. The final benefit is around that yield potential. And we really think you come at the yield potential from two different ways. The first is that you're reducing risk. So you're reducing the risk of the yield loss and all those losses that happen every single year to a grower. So you're reducing the green snap and lodging losses, which just gives you more stability in yield year over year. And we think a lot of growers will appreciate that stability and production stability through that reduced crop loss. And as I mentioned before, that root phenotype that we're seeing has the potential for stress tolerance. And so in those seasons where you get a dry spell or excessive heat, you're going to have potentially better access to water, better access to the nutrients during that time. And those plants are going to withstand that stress a little bit better and maintain their yield through those times. The increased opportunities really come from the overall shorter stature. So now what doors are opened for the grower that maybe aren't as easy to apply with your standard tall varieties? And that really gets after how would I manage my fertility differently, because I can get in there at these different times with equipment that I likely already have in my shed, and get out there and split my nitrogen application, apply with Y drops, be more precise and more timely. And when I put that on, maybe I don't use a fungicide application today because it's too hard to get that scheduled, or the cost is too much. And this just opens a window for me to be able to get in and manage that fungicide application myself. I think a lot of growers are interested in pushing their populations, and they've maybe tried it and not had the return on investment that they expected to get. And so I think this just reduces some of that risk, where growers really can push and try those increased populations where we know we're going to get a little bit more yield, but you're reducing the risk that prevents them from adopting those practices today. So overall, these short stature hybrids bring a lot of inherent benefits in and of themselves, but we're thinking about, how do we help growers capture the full potential value that these short stature hybrids can bring? And so we're thinking about that from an all season long perspective. And so we envision an overall smart corn management system to really make the most out of these short stature hybrids. So thinking about pre-plant, in season, and post-harvest, what are the activities and things that we would maybe do differently and help the grower achieve an overall better outcome than what they're doing today in their tall conventional system. And so we're looking at ways where we can provide field-specific and hybrid-specific density prescriptions. So this specific hybrid has a density response, optimal yield at this population. And maybe that wasn't achievable in a tall system, but in the short system, you can achieve that in your 30-inch rows. You don't have to change your practices from a planting perspective, but you have the ability to push that population and take less risk and get that yield potential and really realize it. Of course, adding all of our latest traits. So our short stature hybrids, when we bring them to market, will have, our Tricepta traits, our Double Pro traits, our SmartStax PRO traits incorporated with them so the growers have everything at their disposal. And then thinking about how the grower, how we work with the grower and partner with the growers to test and learn on the best management practices. So because you can do things differently and you can achieve different timing, do we get a benefit when we apply certain inputs and protection at different times? The timing that we put fungicide on today might just be because we're limited on that access. If we're not limited, do we get a better response with different timing? So thinking through how we co-create, co-develop this system with our growers, with our partners, to understand what the best options are and think through those potential prescriptions to really be outcome-based and shift maybe a grower's opportunity to say, hey, I really want to get this yield out of that field. And if I could, this is what I would do. And have some recognition for the grower to be able to try to hit a target outcome, and what kind of risk protection could we build into that system for the grower and share in that risk. We also want our growers to be recognized for sustainable practices. So we do think that this technology might make it easier for growers to adopt some of those sustainable agronomic practices like no-till and cover cropping, things like this. And split nitrogen applications may have an impact on your water quality. So there's a lot of potential sustainability benefits. And we'd certainly like to work with growers and others to ensure that growers can be compensated and recognized for adopting those practices. And I apologize, I forgot this was a build, so I'm going to build it out. Timing wise, so our breeding native trait technology will be the first to come to market. And that's really because we don't have to go through that regulatory process. And so we're really excited that, we could have the potential to have some pre-launch grower trials out as early as 2023. Depending upon our product availability and our seed availability. So we have been working on this for a while and doing system testing and development, starting to work with academics. We do have some on-farm testing planned for next year with some growers, where we're really going to test all the components of the system and work with them to really test and learn to say, hey, let's really focus in on the inherent benefits of these hybrids and prove out the value of the system to our growers through different density and population protocols, different fertility management protocols, and fungicide and disease management protocols, so that they can really experience all the benefits of the standability, the in-season access, and start thinking about what would I do differently if I have this on my farm, and really get some feedback from the growers on what they're most excited about that this particular product concept would allow them to do. Our initial market research with growers and conversations through field days and demo plots certainly indicates growers are really interested in this technology. They're curious. The standability is the biggest draw for sure. Every grower I've talked to so far, has said, I would definitely try it on my farm and see what it can do. I think the biggest things that they bring out right away is standability and risk reduction in the in-season access and being able to apply fungicide. I think the things they're worried about are ear height placement. So how high is the ear height? Can I still harvest everything? Is that likely to fluctuate very much? And that's certainly something we're concerned about too. So we are continuing to expand our testing in multiple environments to understand what that looks like. Our target is to keep it at 2 feet or higher so that you can harvest easily with the existing equipment. The other thing that growers are concerned about are residue. So they're worried that because of that sturdy stalk, is that stalk going to puncture my tires? Is it going to break down about the same time? Are there any concerns there? And so those are also feedback that we've taken, that we're doing some more experiments to understand that a little bit better. But those are really the only 2 negatives that the growers have mentioned to us. Most of what they're saying is, yeah, let me have some, let me try it, and let's get it out on my farm and see what it can do. So this is super exciting. Okay, so I think I'll pause here and see if we have any questions on short corn. And if not, then we can flip over to the corn rootworm technology and give you a highlight there.
Denise, we do have 4 that are in there, or maybe 5. I don't know if you have the ability to see those. If you don't, I can.
Let me see. I don't see them.
Okay, I can read them.
Okay.
I can read them. First one is, how does nitrogen use differ in short stature corn?
That's a great question. So all of our studies so far indicate that the short stature corns use nitrogen similarly to tall. So we don't see an inherent difference in nitrogen utilization. So we don't expect that to be different. And so what we do expect is that, you know, short corn will respond to those nitrogen protocols similarly to the way tall corn would. The difference might be in that you can apply the timing differently. So how important is that timing to get the outcome, to get the response? That would be the question.
Okay, then the next one was, and you may have touched on this, but what is the yield like between the two cultivars? Does short stature corn have a standard or average compared to standard varieties sized ear?
Yeah, so that is our expectation and how we're evaluating products in our pipeline. So, you know, we're characterizing all the hybrids that we're creating as short in comparison to our tall commercial products as comparators. So we're certainly expecting the yield to be similar and beating those, you know, commercial products that are out there already, similar to our tall. So we evaluate those in standard agronomic practices and look for those hybrids that are high yielding to move forward. And so overall, the structure and architecture of the short corn plant looks almost identical to tall. So you have the same number of leaves, the canopy closes at the same time. The only difference really is the stalk is 30% shorter. The ear sizes are similar. Of course, it depends on the density that you plant that at, but our expectation is that under standard agronomic practices, the yield should be equivalent, but that short stature corn offers you the opportunity to change those practices, increase populations, and manage the system differently to unlock additional yield.
Okay, the next one was, when are you going to be able to tell if water use efficiency improves in short statured compared to standard corn?
Yeah, so we have several experiments that we're doing internally and with academics around variable rate irrigation, rainout shelters that we're trying to leverage, and then opportunistic observations as well in different environments. And so I think in the next couple of years, we expect to have some more information to be able to make some conclusions as to, you know, are we really seeing a stress tolerance, increased stress tolerance with these plants? I think that's certainly something we're excited about. I think the balance is that in some of those tougher acres as well, those drought conditions, your ear height drops too. And so it's going to be a balance of, you know, where the best acres to that this technology brings the most value, and what would we need to do to keep the ear height above 2 feet so that you can harvest that appropriately, because that's maybe the one watch out is, you know, as you go in some of these drought conditions, that ear height can really drop pretty low.
Okay, the next one is, what are the impacts on biomass production with short stature corn? Same or lower? If lower, this would improve residue management, but could impact soil organic matter and carbon, soil erosion, carbon sequestration, etc.
Great question. So overall, planted at the same density, you have about 10% less stalk. The rest of the biomass of the plant is the same. So if planted at the same population, you'll have about 10% less stalk. But we do expect growers to push that population up a little bit. So from an overall residue management, we're expecting probably neutral to potentially more, depending on how high the growers push that population. But overall, it's just the stalk that is about 10% less. Did they answer that question?
We'll find out. I don't know.
Put in a follow-up if I didn't get it.
Yeah. The last one we've got here is from the same gentleman. What are the initial tar spot ratings on these short stature hybrids?
That's a great question. So I don't know because we haven't taken tar spot ratings before on our products. So that's certainly something we're looking at now with the increased pressure. from tar spot. We certainly are going to target next year some areas that had high tar spot this year, so that we can see how our products perform in that kind of environment. Don't know if we'll get the same kind of disease pressure in 22, but we're targeting those potential target tar spot hot spots. And we certainly recognize that the ability to modify the timing of the fungicide might be really important for that disease, and that the short stature hybrids could offer some opportunity there.
That's all we got on the questions for that section.
Awesome. Well, thank you. Those were all great questions. Hopefully, this is something that you can talk about with your growers, and let us know if what other questions growers are having in your areas as well. Okay, so I'm going to shift over to corn rootworms. Put this slide in because I just really like what it demonstrates, in that, I think I've heard over the years that corn rootworm is referred to as the billion-dollar bug. And, over the last maybe 5 years, it's been kind of quiet. Like, we haven't really talked about corn rootworm in a while. The pressure was low, but I think last year and this year certainly reminded us that when the conditions are favorable for corn rootworm, it will become the billion-dollar bug again. So these are just some snippets from some of the articles over the past couple of years. They're back, and they're back with a fury, certainly. So we certainly saw an increased pressure in 2020. 2021 was even worse from a pressure perspective. And so wanted to spend a little bit of time talking about that and what we've seen in the field. And then our newest RNAi technology with SmartStax PRO, that's going to start to be available in small volumes next year, but a larger launch in 23. So this is just a high-level overview of what SmartStax PRO is. So our SmartStax PRO technology is really built on the proven benefits of SmartStax. So it has all the same components that SmartStax has, the same above ground pest coverage, the same herbicide tolerance with glyphosate and glufosinate coverage, and then the same below ground with the Cry 3435, Cry 3BB1, but also now adding a new mode of action through the RNAi technology. And so that's really what differentiates it from everything else on the marketplace, is that it has 3 modes of action for corn rootworm control, and it brings this novel mode of action with RNAi. And I know you guys know this, so I'm not going to spend a lot of time, but I just wanted to call out the differences in how the BT proteins work versus how the RNAi works. And they're really complementary. So, the RNAi technology is totally new and different, works in a very different way, but it's really complementary to the BT proteins. And so, as the bug ingests the root tissue, these BT proteins move into their midgut and binds as an activated toxin. And that opens up pores in the midgut and causes the bug to die. The difference with the RNAi technology is, as the insects are ingesting that root tissue, they ingest double-stranded RNA, and that double-stranded RNA is sequence specific to the messenger RNA of a protein that the bug needs to survive. And so what it does is that double-stranded RNA gets into the cells of the bug. It finds that messenger RNA, which is essentially the instructions to make this protein, binds to that messenger RNA, or the instructions to make a protein, and targets it for destruction. So it gets torn up. Those instructions get torn up. That protein cannot be made. Now, the bug has a little cache of that protein in its cell. So it doesn't die right away because it still has a little bit of protein that it's using. But as that cache is depleted, it can't make any new protein, and then the bug dies. So the difference between this technology and the BTs, which are very fast acting, this may take a couple more days for the bug to actually die. So they can take a few bites while that's happening, if the BTs haven't killed them already. So that's what I mean by this being very complementary. The BTs are very fast acting, and the RNA sweeps up anything that was left if resistance to the BTs existed. or those bugs didn't get enough of a dose. When you look at this product compared to our competition, you can see the differences in modes of action and coverage of the insect spectrum. So these are all the bugs that are covered. You'll see our SmartStax PRO and SmartStax are identical in what it can cover, except for the corn rootworm. So this is really the third mode of action with the RNAi technology for corn rootworm control that's added. And that's what differentiates SmartStax from SmartStax PRO. And our key competitors with Chrome, AcreMax Extremes, and Dirichlet, certainly you can see the differences in coverage from a insect protection perspective. And so this really is the best product on the market for managing corn rootworm today. And 2021 was a key differentiating year in really being able to see that. So I have a little bit of data that I'm going to share with you guys to kind of share with you to show what that data looked like this year. So this is just an overview of the types of trials that we put out this year with our SmartStax PRO. So we essentially did a comparison. So you'll see SmartStax PRO, SmartStax, Optimum AcreMax, Chrome, AgroSure, Dirichlet, and then we had Double Pro with and without soil applied insecticide. So these are all the entries that are in all the trials. And what I'm going to show you is the node injury score data that came from our root digs from these trials. And we've characterized every location based on corn rootworm pressure. And so we'll break that out by pressure, and you'll get to see, how these products performed and what kind of root damage we saw throughout this year. So just one thing to share, this is what our forecast was. So for corn rootworm pressure for 2021, the red and yellow areas are medium to high predictive pressure. And this is based off of data that we capture with our partners on beetle monitoring. So we capture and register how many beetles did we see in this field? Was that a corn on corn field, or was it a rotated field? And we put that into a mathematical model that spits out a prediction to say, okay, based on the beetles you saw in 2020, here's what we think the pressure is going to look like in 2021. And so this was what was predicted. This is what we saw. And so the way we characterize our sites is really based on the Double Pro without soil applied insecticide. As we do those root digs, we give the Double Pro a node injury score. And that's what NIS is, node injury score. That's the root node injury score. And so if the Double Pro had 0 to 0.5 node injury score, we characterize it as no to little pressure. If it was 0.5 to 0.75, we characterized it as low. If it was 0.76 to 1.5, it was moderate to high. And then over 1.5 was very high. And then you can see on this map where those high pressure locations were. And it lines up fairly well with the predicted pressure from the map previously as to where the highest pressure locations are. And that's been fairly consistent, I think, over the years. One other maybe thing I wanted to share, and I think you guys probably know this as well, is, as we think about how we rate roots, we really think about that damage is determined through a node injury score 0 to 3. We already talked about that. At 0.5 or greater, that's really the industry standard to say the farmer's likely to experience economic loss if the nodes have been chewed down to 0.5 or greater. And for each node of root damage, that has a potential of up to 15% yield loss. And you all certainly know there's an increased potential for lodging if a wind event happens as well, which can lead to yield loss for our grower. And so this is just indicating some examples of what that node injury looks like. So at a 0.05, you've got nice healthy roots. At a point of 0.35, you can start to see some of that feeding. These are pretty dramatic instances of feeding that would certainly result in economic damage for our growers. And we also look at lodging. So as we characterize these fields, we look We dig roots and look at the node injury score. We also look for indications of lodging and take lodging scores as well. So this is showing a SmartStax PRO plot standing nice and tall and at the same location. This is a double PRO crop that was lodged in this pressure. So now the data. So we had about 40 locations that had low or 0 to very high pressure. So this is all 40 locations taken together, and the node injury scored data averaged across all those locations. And it's showing your double PRO controls without soil applied insecticide here on the left, your double PRO with soil applied insecticide, AgroSure, Chrome, Optimax Extremes, your SmartStax, and SmartStax PRO on the end. And so again, this is all of the data across all locations, indicating that average node injury score for each of these products. I'm going to show you now broken out by location type. So this is the low pressure location. So as you can see at no to low pressure from corn rootworms, there isn't really a distinction or differentiation between the technologies, which makes sense because there are no corn rootworms to battle. At medium pressure, you really start to see differentiation. So I've marked a line on this graph at the 0.5, which is where we said that's really where the economic threshold for potential yield loss for the grower. And as you can see, SmartStax PRO is way down here at 0.15, but even our SmartStax is still performing quite well under moderate pressure for corn rootworms. And again, yep, sorry. And this is at the very high pressure field. So this is over 1.5 with our double PRO. So that's the node ranging you're getting without any corn rootworm protection on these fields. And our SmartStax PRO really is the only product that's still maintaining below that economic threshold at this level of pressure. And again, this is that level of pressure though, that's really when you're talking with your growers and reinforcing those best management practices. At this number of beetles and amount of beetle pressure, really what the grower needs to do is rotate those fields, control the beetle population, plant a non-corn rootworm traded product with soil applied insecticide, move away and try to get that beetle population back under control so that those pyramided products have an opportunity to work. Because remember, the previous slide, again, this is that moderate pressure. Some of these products are still working fairly well under that moderate pressure, but under that extreme pressure, this new mode of action is really carrying a lot of that weight and helping to manage those corn rootworms. But certainly something to remember and to continue to realize that every product we have out in the marketplace is a tool for the growers to manage corn rootworms, but not intended to be the only tool. So I think we want to continue to think about a diversified approach to manage those corn rootworms and leverage all the tools in our toolbox to ensure that these technologies work for the grower for the years to come. This is a really great picture taken from one of our sites in Minnesota. We dug up 20 consecutive roots within each of these plots. Our SmartStax PRO is up on the top, and you can see the root balls of these indicated here. The root ratings were 0.2 for this particular field. This was a very high pressure field. Our Chrome products are right below. They were rated a 1.4. And you can really see a difference in those roots compared to the SmartStax PRO. Our SmartStax are on the bottom. They were rated a 0.5. And you can see the difference between our double PRO without soil applied insecticide, as well as the AgroSure Dirichlet. This was a 6+ years corn on corn field, so the pressure was very high. This is an aerial view of one of our fields indicating standability and lodging for these. Number 1 is our AgroSure, number 2 is our AcreMax Extreme, number 3 is our Chrome. 4 and 5 are our SmartStax PRO. Our SmartStax is number 6. Our number 7 is our Double Pro, and number 8 is our Double Pro with soil applied insecticide. In this area, which was in Lansing, Iowa, the Double Pro with the soil applied insecticide, almost in all of our areas around here, looked as good as the SmartStax PRO this year, which was pretty amazing and great to see. I think we all know it doesn't always work out that way. We just had just the right conditions to really activate that soil applied insecticide that gave those plants the best protection all season long. So that was a really great indication of when the conditions are right for that soil applied insecticide to be activated. It works really well. So overall, in summary, in our head-to-head comparisons with Chrome across those 40 locations, the SmartStax PRO won 97% of the time. And SmartStax won about 76% of the time. So these are still really, SmartStax is still a really great product on the marketplace. SmartStax PRO is certainly going to be your best coverage from a corn rootworm perspective. But I think we all know that it's really important to think about corn rootworm management holistically and ensure that we're encouraging our growers to take on those best management practices, as well as using these technologies that are at their disposal. This is just a picture of our prediction based on our beetle monitoring data this year of what 2022 pressure might look like. And so again, this is a reminder of what our prediction for 2021 looked like. And here's what we're seeing for potential for 2022. So it's a little bit scary from a pressure perspective. The blue circles here indicate a potential increased risk compared to previous years. So that's something that we certainly want to think about and keep an eye on and continue to think about as we prepare our growers for the next year and their seed selections. From a launch perspective, for SmartStax PRO, as I mentioned, we have some limited volumes available for 2022. So we will have about 10 products that we have some volume behind that will be launched in our branded business next year. And so those limited volumes will be announced here in the next few weeks after Thanksgiving. So we'll have a better idea of how much we'll have, which brands they're going to, and where those volumes will be allocated. But we're certainly targeting those hot spots for corn rootworm control so that this limited supply can be used where it's needed most. And that's really around these green areas here in the map that'll likely get that volume in 2022. We expect to have more volume available, broad acre across both the blue and green areas in 2023 across all our brands and licensees. We will have more plot seed available for 2022 across the brands, across all these regions and with our licensee partners. So you will likely see a lot more SmartStax PRO demo plots plotted out there in addition to the limited commercial volume. Okay, so key takeaways from a launch perspective for SmartStax PRO. Again, this is going to be a product with 3 modes of action. First, opportunity to really get something new and innovative out there with RNAi. It stops the production of a specific protein. That's how it works. That's all it does, and it's very effective. We do see a reduction in adult beetle populations the following year with this technology as a result. And of course, keep in mind all the best management practices. This is one tool. It's certainly not intended to be the only tool. We want to continue working with our growers to provide that diversified management to keep these bugs under control. All right, I know we're almost at time, so wanted to shut up so you can ask a couple more questions.
Not seeing any more, but we can wait a few seconds if anybody has any last
I'll
second.
ask one. What have you guys seen in the field from a rootworm pressure perspective? What are you seeing? What are you hearing? What's working? What's not working?
I'll see what kind of responses we get. People may be typing or may not. One of our members down in Georgia said no issues this season. Now we're getting some more questions. Well, here's another one. Not many rootworm issues in Northwest Central Ohio. Mississippi issues are sporadic, but the tech is good insurance. Couple of other questions. What are some yield differences in damage score on rootworm?
Yeah, so that's a great question. You know, as I mentioned before, each node injury typically results in up to 15% loss. We're still collecting all of our yield data right now from those trials where I showed the node injury score, so I don't have that data yet. But we are expecting to see yield differences where in between like the heavy pressure versus the low to moderate pressure. So I'll keep you posted on that. But yes, typically what we've seen historically with growers in that is as that injury gets above a 0.5, you do have yield losses, and that can vary, of course, based on whatever the historical yield is in that area. But I mean, you're looking at anywhere between 10 to 40 bushels loss, depending upon the damage that you had.
Another one, any thoughts on the rootworm pressure with the corn and soybean prices driving acres?
Yeah, so, you know, we definitely know that the corn rootworm pressure stays high in those corn on corn acres, and certainly more than 3 years of corn on corn, because you're just preserving the best food that those corn rootworms like when you plant corn again. Although we have seen some instances of extended diapause in some areas where even though growers rotated to soy, the eggs decided to wait a year to hatch until you put corn back on. And so that offers an additional challenge for growers as well when they're trying to rotate and still don't get the benefit of that rotation. So that's not widespread, but we certainly see instances of it. Overall, you know, we had a lot of years there where we didn't have hardly any pressure. So I think it's not just the crop rotation, but certainly the weather and having those favorable conditions to really drive those populations up plays a big component. As prices for corn go up, growers want to plant corn. So I expect that we'll continue to have increased corn acres as well. So I don't think that the pressure will change in the coming years. I think we're going to continue to need to address this challenge. But again, it's not everywhere. Not everywhere is experiencing the same pressure, even in the same, you know, state or county or region. Not every field experiences the same pressure, and that pressure isn't uniform within that field. Same thing with resistance. The resistance that the bugs are developing is a spectrum. So where growers are having challenges and problems with the products they have at their disposal today, that's not widespread, but there are pockets. And so I think we'll really be focusing these products in areas to address those challenges where they exist. But I think those challenges are going to be here for a few years.
Looks like that's all the questions we had.
Denise?
Awesome.
Yeah. Could I slip one in here? As you know, I'm in California, so out here water is everything. And I know in the Midwest that may or may not always be an issue, but I was thinking in terms of the differences between the short versus standard corn and whether we've seen opportunities where maybe the short statured could go longer without needing irrigation, or maybe irrigate less often if
Yeah.
need be, and if there's any documented data, maybe on in terms of overall water use, comparing the two.
Yeah, no, that's a great question. And we're leveraging primarily our learning center out in Gothenburg, Nebraska for a lot of these studies with variable rate irrigation. And yeah, so I do think that we have initial preliminary data that would indicate that it's possible. It's possible you could take a different watering regimen with the short stature corn and still have good results. We still have to do a lot of experimentation in this space, in my mind, to validate that. But we certainly do see with that root phenotype we're observing, we're assuming it's because of that root phenotype, but we don't know for sure. But these plants do seem to weather those tough times a little bit better than their tall counterparts. And so it's really promising results and interesting data. I think we need to do more. We need to test it more. We need to push the product concept to its limit to really understand what it can do and what opportunities it could open for growers. But I do think there's a potential opportunity there.
Well, if we don't have anything else, Denise, thank you very much. And thank you to Jim Rascosi as well and Bayer Crop Science for your support of NACAA. This was a very informative session. And just a reminder to everyone that's still on, is I'll be sending out an evaluation, and we'll have the have it posted on YouTube here within the next 24 hours. So thank you again.
Thank you so much for the opportunity. Great to speak with you all.
Yep. Take care.
Thank you, Scott.
Take care.